Number 9, what is the relationship between enthalpy of vaporization of a metal? Okay, remember enthalpy of vaporization is just a very quick, we don't actually have to understand what enthalpies are and necessarily what vaporization is. This is just the amount of energy needed to turn metal into gas. Now conceptually what's happening here is we're taking this solid, okay, we're taking this solid metal sample, and we're turning it into a gas, okay? And so what's happening is we are functionally, successfully adding enough energy to the system to overcome that positive to negative electrostatic attraction, right? Because that's pretty strong there in that metal sample. That's why metals are so strong. But if we add enough energy, and I mean quite a bit, okay, and if you add enough energy, you can overcome that electrostatic attraction, and you can allow those different ions to completely separate from one another. Okay, you can successfully pull them apart, and that's what it means to be a gas. And we'll learn about that later in chapter 10, I believe. But what is the relationship between the enthalpy of vaporization, okay, the ability to turn metal into a gas, of a metal and the strength of the bonds that hold it together? What's the relationship? Well, if the enthalpy of vaporization is the amount of energy needed to put into the system to overcome the electrostatic attraction, the more energy you put in, that means the more attraction they were experiencing in the first place. And if you don't have to put as much energy in, that means they were experiencing less attraction in the first place. Okay? So the relationship is the greater the metal's enthalpy of vaporization, the stronger the metallic bond. Simple as that. Okay. So now that we've covered this idea of metal's strength, or so metallic bond strength being kind of measured or associated with its heat of vaporization, with all three types of major bonding that we have, covalent, ionic, and metallic, we now have some sort of measure of the bond strength. With covalent bonding, it's bond energy. With ionic bonding, it's lattice energy. And then with metallic bonding, it's enthalpy of vaporization. All relate the strength of that metallic bond. 10. Draw two diagrams of a metallic bond. In the first diagram, draw a weak metallic bond, and in the second, show a metallic bond that would be stronger. Be sure to include nuclear charge and the number of electrons in your illustrations. Now, if you refer back to, let's take a look at it. Number 5, okay, number 5, in general, the strength of the metallic bond, blank, moving from left to right on any row of the periodic table, we concluded that was A, increases, okay, because we are increasing the magnitude of the positive charge that that metal cation has when it ionizes. And so what I'm going to do is I'm going to draw a metal over here for the stronger one that's simply further to the right. Okay, and how is that going to look? I'm going to have a couple different metals, okay, a couple different metals over here. What I'm going to do is I'm going to indicate that there is less positive charge in these nuclei compared to these nuclei. So over here they're going to have more positive charge. And I can do that as simply as 1 plus mark over here, and maybe, I don't know, 3 plus marks over here, just so no one gets confused. 3 plus marks over here. And so over here, having 1 plus marks, just say we form like these are +1 ions, that means that each of these have dedicated 1 electron to this structure. Over here, each one has donated 3 electrons. And so there are more electrons in the electron C to bind these cations together. And the magnitude of the positive charge of each of these ions is greater. So the magnitude of the attraction to each of these individual negative charges itself will be greater, resulting in a stronger bond. So, weaker bond on the left, stronger bond on the right.